So I'm doing the AP Calc AB FRQ question from 2011. My question was number 6, and they give you that f of x is going to equal 1 minus 2 sine of x when x is less than or equal to 0, and e to the negative 4x for when x is greater than 0. So for part A, the question asks that you show that f is continuous at x equals 0. And the way that you have to show that something's continuous is that the limit on both sides go to the same point and that the function exists at that point. So that's what's critical for finding whether something's continuous. And right below is where I'm showing in orange that the limit on both sides of 0 must equal to the function at 0. So what we're going to do is we're going to find the limit of 0 from the left side. And because that's a negative value, we have to use the top function. So it's going to be 1 minus 2 sine of x. And when you plug in 0 for that, you're going to get 1 minus 2 times 0, or sorry, 2 times 0, which is actually 1, sorry. Therefore, 1 minus 0 is going to equal 1. And now we're going to find the limit from the right side, 0, as we approach 0 from the right side, of e to the negative 4x, and e to the negative 4 times 0 is going to be e to the 0, which is just going to equal 1. So now that we have that both limits equal each other, you want to find if the function at 0 equals 1, which it does. Therefore, the limit as x approaches 0 of f of x equals the function at 0. Therefore, we know that f is continuous at x equals 0, and we solve the question for part A. Also, the AP scoring guide says that part A was worth 2 points and they're both given to analysis. So it's crucial that you show that the limit of x from both sides equals 1, as well as the function, so f of 0 equals 1 as well, and that you show that because the limits of both sides equal the same thing, as well as the function of 0, that it's continuous. So now we're going to start part B. Part B asks that for x does not equal 0, express the derivative of f of x as a piecewise defined function. Find the value of x for which the derivative of f of x equals negative 3. Basically, this question is asking us to take the derivative of the piecewise function, so the two functions they gave us before, as well as finding the value of x, which one of the derivative functions is going to equal negative 3. Now, first we're going to start by taking the derivative of 1 minus 2 sine of x, and sine of x, the derivative of sine of x is cosine of x, so the derivative of 1 minus 2 sine of x is going to be negative 2 cosine x for the values where x is less than 0, and the derivative of e to the negative 4x is going to equal negative 4e to the negative 4x for the values of x that's greater than 0. So for the second part of the question, we have to determine which function to use to find the value of x in which the derivative of the function equals negative 3. We can automatically rule out that the negative 2 cosine of x will never equal negative 3 because it'll rotate in between negative 2 and 2, since cosine goes in between negative 1 and 1. You can tell from this graph that it will never exceed these points, so it can never equal negative 3. That's something that the AP test requires you to know. So now we have to use a second function and just simply set it equal to negative 3 and try solving for x. So we're going to divide both sides by negative 4, and then we're going to take the natural log of both sides, so we get negative 4x equals natural log of 3/4, and then you get that x equals negative 1/4 ln of 3/4. So 2 points are given to finding the derivative of f of x, and 1 point is given to finding the value of x. It's crucial for this problem to just know that cosine will never equal negative 3 for that function. So for part C, the question asks that you find the average value of f on the integral negative 1 and 1. We can already tell, just looking from the interval, that it's split between the piecewise function, since the piecewise function has two functions for values that change at 0. So I think that's what the AP test is actually testing us on in this question, is that we make sure that we split up the integral between the two functions. So the average value function is actually going to be 1 over b minus a times the integral from b to a, or a to b, of f of x dx. And then when we incorporate that into our actual problem, we're going to get 1 over 1 minus negative 1 times the integral from negative 1 to 1 of f of x dx. So we're going to get 1/2 equals, or 1/2 times negative 1 and 1 f of x dx. So now we're going to split the integral like I was talking about before. So we're going to get 1/2 times this big mess, which is going to be the integral of negative 1 to 0, 1 minus 2 sine x dx, plus the integral of 0 to 1 of e to the negative 4x dx. Now we're going to multiply this another big mess by 1/2, and what's going to be inside the big mess is going to be x plus 2 cosine x from negative 1 to 0, plus negative 1/4 e to the negative 4x from 0 to 1, and that's going to be multiplied by 1/2 once again. And then what we're just going to do is plug in those values for each of those antiderivatives. We're going to get 1/2 times 3 minus 2 cosine of negative 1 plus negative 1/4 e to negative 4 plus 1/4. Now, that's the answer that the test will actually take, but in the solution guide and the scoring guideline, they also have that the average value equals 13 over 8 minus cosine of negative 1 minus 1/8 e to negative 4, which is also an acceptable answer. So part C is worth 4 points, 1 for getting the correct integral split up over the interval, and then 2 for getting the antiderivatives correct, and 1 point for getting the answer correctly. Thank you for watching my video, and I hope it really helped you. Have a great day.